We're here to solve this Shape Sudoku I wrote called Offset Frame. And the trick for a lot of Shape Sudoku, particularly examples like this with no numbers in the grid, is to look at oddities in the shapes. And one of the things in Sudoku is always the no repeat rule. So seeing there are two fours, and in the shape also two fours, and a last shape with a four. The star of this grid is observing that the fours will be important, and we'll need to figure out how to place them through the grid into regions that stretch across multiple boxes. So like this can't be the four shape, but this can be the bent four, the bent four, and the bent four. This can be the large L and the large L, but not this one, which is in one region, and not this one. And I'm marking in the colors the cells that would contain the fours. Obviously the whole shape is part of what's there. And the last four is just going to be a singleton that's going to be on the right side of one of these L's. So here, or here, or here, or here. So all the cells that could contain these 5 fours are now marked. And what we then want to think about is that there is a particular option with these blue clues that's more concerning, and it's particularly about this cell, which takes away 2 in this box and 2 in this column. If neither of these cells could contain fours, we now have to get 3 fours across these 3 positions, which you see quickly breaks down here. So this cell is incompatible with the rest of the grid working. These, though, down below are fine. So this is 4, 7, 4, marked in this way. And we'll just mark down below that we have that whole shape in the grid. That eliminates this position for a red and for a green. So we're now in the case that the 4, 4 has to be the doubled clue has to be one of these, which means this red 4 cannot be one of these. It has to be this one. And that actually means that the doubled 4 has to be over here to dodge this cell, which would be in the same region with the other. So we have placed all of these. Let's not forget that that other 4 comes with a 5. And we actually have 2 shapes left to go of this smaller L category, and it's probably useful to mark them in. I guess I'm the constructor of this puzzle, so I'll tell you it is useful to mark them in as containing the options of those digits. So across them, they'll have a full set of these, so it's useful to know that this will be a 1-7 pair, and this will be a 6-8 pair. Next stage to make progress in the puzzle is probably still going to be about the numbers we now have in the grid. So 5 and 7 look like good numbers to think about. So let's sort of see how they play out. We definitely have 2 more shapes with 5s over here, and across the 1x3 groups, there are 2 1x3s that have those 5s, and actually 5 always comes with 3 in those sets. I see 2 always comes with 6 in the other sets. But right now the 5 isn't sort of on the outside, and all of these 5s are on the outer frame pieces. So actually the 7 looks like a more key digit. 7 is going to run into conflict with the 7s in these long groups. And one thing you can see is this 6, 7, 5 can't go here, so there are 2 options for this. And the 7, 1, 8 can't come up here, and there are 2 options for that. And looking across those, which is more attractive to think about, this may take a little bit of time, but there's actually a shared number across 2 of these L shapes. So the one that eliminates this 7, 1, 8, which is this setup here, has to be one of these in red. And while we don't know which of the 2 it is, we know it's going to take a 5. And 5 now, because it's part of these 1x3s, makes those incompatible. So there are only 2 1x3s that can still be up top. They will take a 2 or a 6 in the space, and across this whole range will be both 2 and 6. And here is where the next key aha, which probably slowed some solvers, is it's actually forced at this time that it has to be the one that's got a center 2. And that's again seeing that these 2 L shapes as they go, one of these digits will be exactly a 6. This would see this, and this would see this. And so the option of 6 is removed from the cell. And so this is 2 with 1 and 6 surrounding it. So we'll mark this in as being placed. How does that work out for us? Well, now let's think about this next position. And we have a 1 and a 6 in 2 of the L's that would go into the space. And so both of those are eliminated. So this has to be 8, 3, and 5. Having that 8, 3, 5 in means that the 5 that went up here is from the 5, 7, 6. And the last shape of 7, 1, 8 is forced. So we have all the big L's in the grid now. So we'll color these in. Now thinking to the 1x3s, this 3, 5 in this column means that these across here will have to be the 2, 6, 8. That means the two remaining are 3, 5, 8, 5, 3, 9. One of those goes here, but it can't have an 8 in it, so this is going to be 5, 3, 9. I got two 5s up above, so 5 is going to be over on the left side here. And that means this last one to go is 5 with 3 and 8. So we actually have all the shapes conceptually placed. So we don't have to think about the inventory as much anymore, but we will have to do some Sudoku to get to the end here. And the key Sudoku is really going to start by looking at the very top. Cell like this actually is a naked single of a 9, and this is actually the only place a 3 can go in that top row. So this has to be 8 over 3. That being 8 over 3 means this 6 was 1. That makes this the 7, 8. That 6 moves this 6 over here, puts in this as a 1. This 8 puts this 8 up top, 2 down below, 4 to finish that row, 9 to finish this column. This is 1, 2 to finish this column. We have 2 and 6 to finish this space, but 2 can't go in the cell ones are in that column. So this is 2 here and 6 here. Let's see, we've got a 3 cutting across this space, so we need a 3 in the cell, which gives us a force 3 here and a 3 in one of these cells. This middle box now has just one space left for a 6, which gives me one space for a 7, which gives me one space for a 2, and a final 9 that comes to the top and puts in this 9. I need 8 and 7 over here. So those all look good. This 7 puts in a 7 in this cell. I have 1, 2, and 9 to finish this out. This has to be the 9. The 2 down below puts a 2 in here, puts a 1 in here, gives me a 1 and moves over a 3. I really am not going to make progress. These will be lots of pairs. Like this 9 is the only unique number that's going to help here, so let me instead come to the top. This is a 4 and a 5, and this is a 1, 2 set. This is a 7 and a 9, and that 7 is an important number, so that 7 gives me this 9, which gives me this 9. That 5 now comes down here, and now I have enough. I'm going to make progress here. This is 5 and 3 and 3 and 8 and 8 and 4 and 4 and 6 and 6 and 1 and 1 and 2 and 2 and 7. We have 5 and 9 to go here. We have, let's see, this is 6 and 2. Gives me 2 and 1 and 1 and 8. So we've made it through to the finish. So hopefully got something from the initial discussion I gave about how to visualize these puzzles and ways to mark in cells. For sure, getting the 4 placements was the first thing in the grid, but finding that there's a pair of 6 and 8 that work together up in the cell, particularly after you know that this is a 5 from that bent L. It's 2 distinct hard ahas. They add together to a Saturday puzzle, but hopefully you got something from watching this video. If you were stuck, worked through at least one or both of those ahas if they were what were tripping you up. Thanks. We'll see you again soon.